According to the National Electrical Code, specifically the 1981 edition, Article 314.25 addresses the accessibility of junction boxes. This article states that junction boxes employed for the connection of conduits, cables, or raceways shall be accessible. The key term here is accessible. The code intends that electrical connections within junction boxes can be inspected, maintained, and modified without causing undue damage to the building structure or finish. An exception to this rule exists. It states that raceways concealed in walls, ceilings, or floors shall be considered accessible from the nearest accessible point. This exception means that while the raceway itself may be hidden, there must be a way to access it for future work. This exception does not apply to junction boxes that are completely inaccessible. The question arises whether junction boxes sandwiched between a Formica backsplash and an exterior wall, with no access panel, comply with the code. Given the information and the code's intent, such installations likely violate the accessibility requirement. The National Electrical Code has consistently mandated junction box accessibility for inspection and maintenance. Even though the 1982 National Electrical Code might not have explicitly mentioned junction boxes behind backsplashes, the general accessibility rule would still apply. Therefore, burying junction boxes in a manner that renders them completely inaccessible is generally not permissible under the code. There might be a misunderstanding of the disclosure stating to current code. This could be interpreted in two ways. Firstly, it might mean that the work complied with the code at the time of the 1982 remodel. Secondly, it could mean that it adheres to the code in effect when the house was sold. Based on the 1981 National Electrical Code and its accessibility requirements, it is probable that the junction boxes were not installed according to the code prevailing at the time of the remodel, given that they are now inaccessible. It's crucial to note that the electrician's assertion that the accessibility rule is a relatively recent addition is incorrect. The necessity for accessible junction boxes has been a long-standing tenet of the National Electrical Code. If junction boxes are indeed inaccessible, several actions can be taken to rectify the situation. Firstly, access panels can be cut into the backsplash or wall to provide the required accessibility. This approach allows for inspection, maintenance, and any necessary future modifications to the wiring within the junction boxes. Secondly, consider replacing the inaccessible junction boxes with accessible ones that meet current code standards. This might involve relocating the junction boxes to a more accessible location, such as behind an appliance or under a cover plate in a cabinet. When undertaking any electrical work, it is essential to ensure compliance with all applicable codes and regulations. Therefore, the entire electrical system should be inspected to identify any other potential code violations. This comprehensive approach helps ensure safety and prevents future problems. For instance, ensure that all wiring is properly sized for the intended load, grounding is adequate, and overcurrent protection devices are functioning correctly. In the context of electrical codes and practices, several key aspects warrant a more detailed explanation. This involves discussing wire sizing, overcurrent protection, grounding, and other critical electrical components and concepts. Proper wire sizing is paramount to prevent overheating and potential fires. The National Electrical Code provides tables, such as Table 310.15b16, that specify the allowable ampacities of insulated conductors based on their size, insulation type, and ambient temperature. When selecting wire size, it is crucial to consider the load it will carry, directing factors for ambient temperature, and the number of conductors in a raceway. For example, a 14 American wire gauge copper conductor with type THHN insulation is typically rated for 15 amps under normal conditions. However, this ampacity may need to be derated if the conductor is installed in a hot environment or bundled with other conductors. Overcurrent protection, provided by circuit breakers or fuses, is another critical safety measure. These devices are designed to interrupt the flow of current if it exceeds the safe ampacity of the conductors or connected equipment. The National Electrical Code Article 240 addresses overcurrent protection requirements. The general rule is that overcurrent protection should be sized to protect the conductors it feeds. For instance, a 14 American wire gauge copper conductor protected by a 20 amp circuit breaker would violate the code, as the breaker is rated higher than the conductor's ampacity. Grounding is essential for providing a safe path for fault current to return to the source, trapping the overcurrent protection device and preventing electrical shock hazards. The National Electrical Code Article 250 covers grounding and bonding requirements. A properly grounded electrical system ensures that metallic enclosures and equipment are at ground potential, minimizing the risk of electric shock if a fault occurs. Grounding electrodes, such as ground rods or metallic water pipes, are used to connect the electrical system to the earth. Bonding is the process of connecting all metallic parts of the electrical system together to create a low impedance path for fault current. Bonding ensures that all metallic components are at the same electrical potential, reducing the risk of shock. In addition to these fundamental concepts, understanding voltage drop is crucial for ensuring efficient and reliable operation of electrical equipment. Voltage drop occurs when the voltage at the load is lower than the voltage at the source due to the impedance of the conductors. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The National Electrical Code recommends limiting voltage drop to no more than 3% for branch circuits and 5% for feeders. To minimize voltage drop, use larger conductors or shorten the length of the circuit. Another important consideration is arc fault circuit interrupters, known as arc fault circuit interrupters, which are designed to detect arc faults, a common cause of electrical fires. The National Electrical Code requires arc fault circuit interrupters protection for branch circuits that supply outlets in dwelling units. Arc fault circuit interrupters devices can detect the unique characteristics of arc faults and trip the circuit, preventing a fire from starting. Ground fault circuit interrupters, known as ground fault circuit interrupters, are another essential safety device designed to protect against electrical shock. Ground fault circuit interrupters devices detect ground faults, which occur when current leaks to ground through an unintended path. The National Electrical Code requires ground fault circuit interrupters protection for outlets in bathrooms, kitchens, and other wet locations. These devices quickly interrupt the circuit when a ground fault is detected, preventing electrical shock. Electrical installations must comply with all applicable codes and regulations, including the National Electrical Code, local amendments, and any other relevant standards. Electrical inspectors enforce these codes to ensure the safety of electrical installations. It is essential to obtain the necessary permits and inspections before starting any electrical work. Working with a qualified and licensed electrician is also crucial to ensure that the work is done safely and correctly. When performing electrical work, always follow safe work practices. These include energizing circuits before working on them, using appropriate personal protective equipment, and following lockout/tagout procedures. Lockout/tagout procedures involve disconnecting the power source and placing a lock and tag on the disconnect switch to prevent accidental energization of the circuit. Regular maintenance and inspection of electrical systems are essential for identifying and addressing potential problems before they become safety hazards. This includes inspecting wiring, connections, and overcurrent protection devices. Addressing any issues promptly helps ensure the continued safety and reliability of the electrical system. Understanding the basics of electrical theory is also helpful for troubleshooting and repairing electrical problems. Electrical theory covers concepts such as voltage, current, resistance, and power. Understanding these concepts helps in diagnosing and resolving electrical issues. Furthermore, staying up to date with the latest electrical codes and technologies is crucial for electrical professionals. The electrical industry is constantly evolving, with new codes, standards, and technologies being introduced regularly. Continuing education and training are essential for staying informed and providing safe and reliable electrical services. Consider the implications of using aluminum wiring in older homes. While aluminum wiring was sometimes used in the past, it poses a higher risk of fire compared to copper wiring. This is because aluminum expands and contracts more than copper, leading to loose connections and potential overheating. If a home has aluminum wiring, it is essential to have it inspected by a qualified electrician. There are several options for addressing aluminum wiring, including replacing it with copper wiring, using copper pigtails to connect aluminum wires to devices, or using special connectors designed for aluminum wiring. The choice of method depends on the specific circumstances and budget. Another aspect to consider is the use of surge protection. Surge protection devices protect electrical equipment from voltage spikes caused by lightning strikes or power surges. These devices divert excess voltage to ground, preventing damage to sensitive electronic equipment. Surge protection is especially important for computers, televisions, and other electronic devices. Surge protection can be installed at the main electrical panel or at individual outlets. It is also important to understand the requirements for smoke detectors and carbon monoxide detectors. Smoke detectors are required in all dwelling units to provide early warning of a fire. Carbon monoxide detectors are required in dwelling units with fuel-burning appliances or attached garages to provide early warning of carbon monoxide poisoning. Smoke detectors and carbon monoxide detectors should be tested regularly to ensure that they are functioning correctly. They should also be replaced every 10 years, or as recommended by the manufacturer. When working with electrical systems, it is crucial to use the right tools and equipment. This includes insulated screwdrivers, pliers, wire strippers, and multimeters. Using the right tools helps ensure safety and makes the work easier and more efficient. Multimeters are used to measure voltage, current, and resistance. They are essential for troubleshooting electrical problems and verifying that circuits are properly energized. It is also important to use personal protective equipment, also known as personal protective equipment, such as safety glasses, gloves, and insulated footwear. Personal protective equipment helps protect against electrical shock, burns, and other injuries. Always disconnect the power before working on electrical circuits. Verify that the circuit is de-energized using a multimeter before touching any wires or components. Never work on live circuits unless absolutely necessary, and then only with appropriate training and personal protective equipment. Be aware of the potential hazards of working around water. Water is a good conductor of electricity, so it is essential to avoid contact with water when working on electrical circuits. Never use electrical appliances or tools in wet or damp locations. If water is present, disconnect the power and dry the area before proceeding. Respect electricity and always follow safe work practices. Electricity is a powerful force that can cause serious injury or death. By following safe work practices and using the right tools and equipment, you can minimize the risk of electrical accidents. If you are not comfortable working with electricity, hire a qualified and licensed electrician to do the work for you. It is always better to be safe than sorry when it comes to electricity. In summary, the 1981 National Electrical Code emphasizes the accessibility of junction boxes for inspection and maintenance. Accessible junction boxes, such as those hidden behind backsplashes, likely violate this code. Corrective actions include cutting access panels or relocating the junction boxes. Ensure compliance with all applicable codes and regulations, and prioritize safety when working with electrical systems. It's crucial to consult with a qualified electrician to address any electrical issues and ensure that the work is done safely and correctly. Consider exploring energy-efficient lighting options such as light-emitting diode, also known as light-emitting diode lighting. Light-emitting diode lights are more energy efficient than incandescent or fluorescent lights, and they have a longer lifespan. Replacing old lighting fixtures with light-emitting diode fixtures can save energy and reduce electricity bills. Be mindful of the importance of electrical safety in the home. Educate yourself and your family about electrical hazards and how to prevent them. This includes teaching children not to play with electrical outlets or cords, and ensuring that all electrical appliances are in good working order. Regular electrical safety inspections can help identify potential problems and prevent accidents. Finally, remember that electrical codes and regulations are constantly evolving. Stay informed about the latest changes and updates to ensure that your electrical installations are safe and compliant. The National Electrical Code is updated every 3 years, so it is important to stay current with the latest edition. By following these guidelines and recommendations, you can help ensure the safety and reliability of your electrical system. Always prioritize safety and consult with qualified professionals when needed.